This is a trig subproblem, so we're going to put everything in terms of theta to help us integrate this. Now, I like to start with what I call the main thing, or the tell, because it tells you which triangle you're going to use. Now, the main thing, or the tell, whatever you want to call it, is always going to be a square root that contains an x squared and an a squared. And so in this case, we have this as our main, where a is 1. Not because it's 1 over here, but because 1 squared, that's the a squared. The 1 is the a, okay? So then what I do is I say, okay, well this looks to me like it's x squared plus a squared, given that a is equal to 1. So then I go to my triangles on the back of my exam, right, because I write them down once on my scratch paper on my exam, and I figure out which triangle gives me square root of x squared plus a squared. So this is minus, this is minus, this is plus, and it's x squared plus a squared. So this is the triangle that I'm going to use. Now that I have the triangle, what I'm going to do is I'm going to find this, but in terms of theta. So what I like to do is put what I want to find at the top, so a squared plus x squared. I don't use numbers, you can, but I don't. I just like saying a is equal to 1, and then putting everything in terms of variables here. And then at the bottom, I always put a. And then I ask myself, blank of theta is going to give me that. Well, I need to know what those are in terms of theta. So how do I do that? I take the triangle. I'm like, I know this is opposite. This is always hypotenuse. And then this, what's left, is always adjacent, right? So then I say, okay, well, this over here, that's my hypotenuse. And a is my adjacent. So really I'm asking, what of theta is going to give me h over a, because that's what this is here. So to do that, I bring up my SOHCAHTOA, and I ask myself, which one gives me h over a? Well, none of these are h over a, but you have to remember that there are inverses. If this is sine, and this is cosine, and this is tangent, then we know that this is cosecant, this is secant, and this is cotangent. I like to remember it this way: the C and the S's are crossed. So this is really the following, and what gives me h over a is secant. So now I know that secant of theta is going to give me h over a. But remember that I want to have this in terms of theta, so I'm just going to solve for that by multiplying both sides by a. So this becomes a secant of theta is equal to the square root of a squared plus x squared, and that is our first substitution. So now I'm going to go ahead and substitute that. Given that a is equal to 1, that is secant of theta. And now we move on to putting x in terms of theta. So this was finding the main thing. Now let's go ahead and find x in terms of theta. So if I want to find x, remember the strategy is put what you want to find at the top, a always at the bottom, ask yourself blank of theta is going to give you x over a, then you ask yourself, okay, what is x over a in terms of theta? Well, x is your opposite and a is your adjacent. So you're really asking yourself what of theta is going to give you opposite over adjacent, because that's what x over a is. You go back to your SOHCAHTOA and you look for OA. So OA is tangent. So here we're saying tangent of theta is going to give us x over a, but we want x in terms of theta, so I'm going to multiply both sides by a. So that's going to be a tangent of theta is equal to x, and a is 1, so really x is equal to simply just tangent of theta. And that's another substitution that we have. So I'm going to go ahead and take this x and replace it with tangent of theta. 1 is still just 1, but we still have to replace dx. So we're going to go ahead and find dx, which is really just x prime. If we have x is equal to a tangent of theta, then x prime is going to be a secant squared of theta, d theta, because we took the derivative, and dx is x prime. So that means that we have here another substitution. So remember, a is just 1, so it's really just secant squared of theta, so I'm going to go ahead and replace my dx with secant squared of theta, d theta. Now lastly, I have to replace my bounds and put them in terms of theta, because right now they're in terms of x, right? X is equal to 1 to x is equal to square root of 3. So we have find our bounds. If we have that x is equal to the square root of 3 and x is equal to 1, then what is theta? well, we actually have to find what theta is. So find bounds is really finding theta as well. So what I do is I always like to take this equation over here. So if x is equal to a tangent of theta, and a is really just 1, then to find theta, what I can do is first get rid of the a, right? Divide both sides by a, so we have tangent of theta is equal to x over a, and we know that to find theta, we just take the inverse, right? So that's going to be arctangent of whatever's here is equal to theta. So that's our little equation here that we can use to find theta, given that x is square root of 3 and that a is equal to 1. So in this case, theta is equal to arctangent of x square root of 3 over 1, which is just square root of 3. And then here, arctangent of 1 over 1, which is just 1. Now, arctangent of square root of 3 is just pi over 3, and here this is pi over 4. And I'll go ahead and prove that to you if we take our little unit circle. I always like to think pi over 3 is over here, because I know that this is pi over 2, and 2 and 3 are close to each other. And then to find the actual coordinates, what I like to think is 3, 2, and then 1, and they're always over 2, and so if this is 1, then the opposite is going to be true, square root of 3 over 2. So in this case, we're asking tangent of what angle is going to give us square root of 3? Well, it's going to be pi over 3, because if we take tangent, remember, tangent is just sine over cosine, or y over x if you want to think about it like that. So square root 3 divided by 2 times 2, that gives you just square root of 3, right? Because I just took the 1/2, took the reciprocal, which is 2, and we got square root of 3, so we got that. And then the pi over 4, and if we take square root of 2 over 2 divided by square root of 2 over 2, it's the same thing, it's just 1. So tangent of what angle is going to give us 1? Well, that angle is pi over 4. So we have that theta is equal to pi over 3 and pi over 4, so I'm going to go ahead and plug those in. All right, and now we have our integral all in terms of theta. Isn't that beautiful? So all this work was just to get everything in terms of theta. Now we're actually going to solve the integral. First thing I see is that one of the secants can go away. 1 tangent of theta, and then we still have a secant theta. I'm just going to move it over here to the top. Secant theta d theta. Here's an interesting strategy that you must be aware of. We can convert these to sines and cosines. That secant is just the inverse of cosine. See that right over here. So we can make secant 1 over cosine of theta, and I know that tangent is just sine of theta over cosine of theta. Now if we know if we have something like this, we can just multiply by the reciprocal, so we have 1 over cosine of theta times cosine of theta over sine of theta. These cancel out, and we're just simply left with 1 over sine of theta. And we know that 1 over sine of theta, is really just cosecant, because 1 over sine of theta means inverse, right? And the inverse of sine is cosecant. So this becomes cosecant theta d theta. So then at this point, you would just have to know from memory what is the antiderivative of cosecant of theta. And that's going to be negative ln of cosecant of theta plus cotangent of theta, and we're evaluating this whole thing from pi over 4 to pi over 3. Okay, so fundamental theorem of calculus states take this, plug this in, minus take this, but plug this in. Then we draw the unit circle again. Pi over 3, we already know from here it's 1/2 square root 3 over 2. And then we need to find cosecant of pi over 3. Remember, cosecant is just the inverse of sine, so it's 1 over sine. That's going to be 1 over what sine is at pi over 3. So that's 1 over square root 3 over 2, which is the same thing as multiplying top and bottom by the reciprocal. So that's going to be 1 times 2 square root of 3, which is just this, but we can simplify this further by rationalizing the denominator. So this becomes 2 square root of 3 over 3. Then we have cotangent of pi over 3. Cotangent is the inverse of tangent. So tangent here is sine over cosine, which over here is just the same thing as doing this, which cancels out, square root of 3. But remember, cotangent is the inverse of that, so it's 1 over that. So we have that this is 1 over square root of 3 minus cosecant of pi over 4. So remember, pi over 4 is square root of 2 over 2, square root of 2 over 2. Remember that cosecant, same thing, it's 1 over sine. Sine is square root 2 over 2, so 1 over square root 2 over 2 is really the same thing as 2 over the square root of 2. We can rationalize the denominator, and that becomes 2 square root of 2. So that's going to be 2 square root of 2 over 2. Cotangent is 1 over tangent, right? It's the inverse of tangent. So we need to find tangent of pi over 4. Tangent of pi over 4 is 1. Then we need to find cotangent of pi over 4, just 1, because cotangent is 1 over tangent. Tangent is 1, so 1 over 1 is 1. Then we can distribute this negative over here, so this becomes a positive. Note that these 2's cancel out. We can add these over here. Our common denominator is 3 square root 3, so we have 2 square root 3 times whatever is missing. It's missing a square root 3. So then these 2 simply just become 3, which becomes 6, and then we have plus 1 times whatever is missing. We're missing a 3 here, so this becomes 3. So 6 plus 3 is 9. So then if we divide, we get 3 goes into 9 3 times, 3 goes into 3 1 time, square root of 3. So we're left with 3 over square root of 3, but we can rationalize the denominator. These here just become 3, and then we have 3 square root 3 at the top. The 3's cancel out, and we're simply left with the square root of 3. So this over here becomes the square root of 3. We have negative ln plus ln square root of 2 plus 1. This, ladies and gentlemen, is our answer for this problem.